Welcome back. We are going to finish up our first chapter talking about systems still and solving them by elimination. So remember, elimination means I want to eliminate or get rid of one of our variables. And I'll do that by making sure that their coefficients, or the numbers in front, are the same but opposite signs, and then making sure they add to zero that way. So I'm going to start and see I have positive 4 and positive 2. That would add to 6. Positive 3 and positive 1. That would add to 4. So that's not going to get me anywhere. I need to change this. I can choose to either eliminate x or y first. It doesn't matter. I'm going to choose to eliminate y. So if this is a positive 3, then I want to multiply everything in that bottom equation by a negative 3 so that I can get the y's to add to 0. So we are not touching the top one on the bottom. Negative 3 times negative 2x is negative 6x. Negative 3 times positive 1 is negative 3y. And negative 3 times 1 is negative 3. Now, when I add these together, 4 plus negative 6 is negative 2x. 3y minus 3y is 0. And 11 minus 3 is 8. I can finish solving by dividing by negative 2 on both sides. And we get x is equal to negative 4. Now that I've got x is equal to negative 4, I can plug that into either this x or this x in my originals to solve for y. So if I solve for y on the bottom one, I do 2 times negative 4 plus y is equal to 1. Remember, I'm going back to the original, not the one that we made when we multiplied. 2 times negative 4 is negative 8. And to get y alone, I would have to add 8 to both sides and get y is equal to positive 9. So my final answer would be negative 4, positive 9 in ordered pair form. That's going to be the point where my two lines cross. All right. Let's see. Negative 10 and negative 5 do not add to 0. Positive 3 and negative 6 do not add to 0. So I need to get rid of either x or y by multiplying. I'm going to pick y just because they're already opposite signs. So I'm going to multiply this by 2. 2 times negative 10 is negative 20x. 2 times 3 is positive 6y. 2 times 1 is 2. Not changing that second one. When I add these together now, negative 5 minus 20 more is negative 25x. Negative 6 plus 6 is 0y. And 23 plus 2 is 25. The opposite of multiplying by 25 is dividing by 25, and it's negative. So we get x is equal to negative 1. Again, we can put that into either the top or the bottom equation. It does not matter, so that we can solve for y. Let's put it in the top one. Negative 10 times x plus 3y is equal to 1. And again, I changed the x to the negative 1 because that's what we found it to be. Negative 10 times negative 1 is positive 10. I'm going to subtract the 10 to the other side. We have 3y is equal to negative 9. Divide by 3, and y is negative 3. That makes my final answer negative 1, negative 3. For letter B, again, I'm looking 3 plus negative 6 is not 0. 2 plus negative 5 is not 0. I can pick either x or y. It really doesn't matter. I'm going to go ahead and pick x this time. I want this to be a 6, so I'd have to multiply by 2. 2 times 3x is 6x. 2 times 2y is 4y. And 2 times negative 2 is negative 4. I'm not changing the second equation there. So now when I add negative 6 plus 6 is 0. Negative 5 plus 4 is negative 1y. And 2 plus negative 4 is negative 2. I finish getting y alone by dividing by negative 1. Positive y is equal to positive 2. Can plug that positive 2 in for the y on either equation. It really doesn't matter. If I pick the top one, I have 3x plus 2 times y is 2 equals negative 2. 2 times 2 is 4. Subtract 4. Keep the 3x. These add to 0. Negative 2 minus 4 more is negative 6. Divide by 3 on both sides. And x is equal to negative 2. So our solution is negative 2, positive 2. We are going to skip over to example 2. We have a landscaping company. And again, with a word problem, I'm going to start with, what are they asking me for? They're asking me for the cost of one bush and the cost of one tree. So if I make x the cost of one bush and y the cost of one tree, then we can write the equation. Searching through, we have our first order. So 13 bushes. Oops, let's write that so we can see it. We have 13 bushes, so it's 13x, and plus 4 trees, 4y, totaled equals 487. The second order, so we're on a new line, we have 6 bushes, 6x, and plus 2 trees, 2y, totaled equals 232. And so there is my system of equations. Looks like I am probably going to choose to get rid of y, because it would be really easy to multiply this bottom one by negative 2. So my y's would add to 0. So I keep the top one. On the bottom, we have negative 2 times 6 is negative 12x. Negative 2 times 2y is negative 4y. And 232 times negative 2 is negative 464. 13 plus negative 12 is 1x. 4 minus 4 is 0. 487 minus 464 is 23. Wow, that was pretty easy. So we found out that bushes cost $23 each. Now we can use that to find the cost of the tree, or the cost of y. I'm going to take that 23 and put it in here in the second formula because the numbers are a little bit smaller. 6 times 23 plus 2y is 232. 6 times 23 is 138. I'm going to subtract that 138 to the other side. That gives me 2y is equal to 94. Divide by 2, and we get y is equal to 47. So trees cost $47 each. Well, that wasn't too bad. Special solutions. So there's 3 different types of solutions that we can have. We can have one solution, which is when I have 2 lines that cross, and they cross at one spot. This is the ordered pair that we have been finding in all of the problems that we've been working on this lesson and the last lesson. We could have lines with no solution. No solution is because they're parallel. And if our solution is where they cross, parallel lines never cross. They never cross. Well, you can't ever get an answer. And then last but not least would be infinitely many solutions. That's when we have 2 equations that when all is said and done, they're the same equations, just with different values. Like if I had x plus y is equal to 4 and 2x plus 2y is equal to 8, these 2 equations are actually the same line. I just doubled each of these values. That's it. So 2 equations, but only one line. So where do they touch? Well, they touch all along the line. Infinitely many solutions. So what do those special solutions look like when we are doing our math? All right, we can solve these using any method. For letter A, I think I am going to solve using substitution because they're solved for y already. So I think I'm going to take this and put it in for this y. 2x minus 5 is equal to 2x plus 1. I'm going to get my x values together. The opposite of a positive 2x is a negative 2x. 2 minus 2 is 0. X is not there anymore. I have that negative 5 that I'm bringing down. 2 minus 2 is 0. X is not there anymore, and I have this 1 coming down. Well, right now what I see is negative 5 equals negative 1. No, that is not true. Negative 5 definitely does not equal 1. If it's not true, then this is no solution. These 2 lines will be parallel. They have the same slope. Some of you might have said, well, I see that they're the same slope in different y-intercepts, so I know they're parallel, and it's going to be no solution. For letter B, I think I'm going to solve this one using elimination. I think I'm going to eliminate the y. The opposite of a positive 2y is a negative 2y, so I'm going to multiply by negative 2. Remember, everything has to get multiplied by that negative 2. Negative 2 times negative 2 is positive 4. Negative 2 times 1 is negative 2y. And negative 2 times 3 is negative 6. So now when I add these together, 4 minus 4 is 0. 2 minus 2 is 0. So I have 0 over here, then an equal sign. 6 minus 6 is 0. Oh, well, 0 minus 0, that's true. That's a true statement. And so these were actually the same line, and true statements is infinitely many solutions, or IMS. All right, this is where we will stop for today. Thanks again for joining me. Have a great night.